What we're going to do in this talk is we're going to run through some techniques, both kind of theoretical, and then we'll do a little bit of technical work, and then hopefully I'll have a demo at the end that we can both show and then work on adding in some new features into to kind of get used to these concepts, to give you an indication and an idea about how you can go about applying this in the work that you do. So what we're going to do here, our feature is Python and BDD. So as a Python developer, I want to get work done. Easier, quicker, and with no misunderstanding, as this makes my life easier and makes me money in the long run. So the technique we're going to be looking at today mainly is behavior-driven design through Python. So I gave a brief description there. This I find is this is the hardest problem I have to do in my day job. The technical bit, evidently, once you understand what's going on, is trivial. It's about turning just an idea into something. The hard bit is really getting that idea and making sure that both you and the business person giving it to you have the same idea, because you might not, which can be quite difficult. I am sure we are all familiar with this particular slide, and this, I think, very succinctly sums it up. So, what did the customer want? A swing. What did they end up getting delivered? Basically, not really anything at all. Not a product that worked. Not a product that worked for them. So, a brief overview about myself. I am by training a robotics engineer. I did a degree in the University of Limerick. As part of that, I swiftly discovered that I very much more like the software side than the hardware side. I have now been working with Python for 5 years, I think just over 5 years. As part of that, I have worked in a few different industries. So in manufacturing, in kind of web and cloud hosting, and now currently I work in financial services. At the moment, I am a team lead and senior software engineer, so I look after a multinational team of 8 to get things done and help deliver product. And then also, I am not particularly good at CSS, so both the website and this is a bit plain, but it is definitely functional on what the customer wanted. We can make it pretty afterwards. Final point, like the entire BDD process, feel free to ask a question at any point. I will try and adapt my timings to make sure I get through everything correctly, but the whole BDD concept is about both sides being engaged, about both sides coming to an understanding quickly. And I find that doesn't tend to happen if one side just sits there silently and then says, okay, and then comes back a month later kind of going, I didn't understand what you want. So feel free to ask questions. So I'm sure, some of you have heard these things before. So someone will come to us, we'll do something, and then about a week later, you'll hear the words, I thought it should be this, it wasn't in the requirements, if only we'd thought of that, what we're doing is outside the scope of this, or other kind of ambiguous words like that. So this all basically boils down to the communication gap between the person giving you and trying to explain to you what they want, and then also you interpreting that and trying to actually deliver on that. This one is my favorite. I want you to make it work like it does now, but with these new things. So I want you to make it work exactly like it does now, but different, which obviously enough is a very, very, very hard thing to do. So this, I think, is actually probably the biggest quote I've come across that sums up this entire thing, and it's from the Cucumber book, which is a great book. Cucumber initially came from more Java land, so the book is a little bit focused on that, but it does give you some very good insights in here. So what this says is, instead of a business stakeholder passing on requirements to the development team without much opportunity for feedback, i.e. here's what I want, go do it, don't talk to me, the developer and stakeholder collaborate to write automated tests that express the outcome that the stakeholder wants. I think that is absolutely critical. That is ultimately what the person really, really wants, no matter what they say. They want you to give them something that delivers what they want. So in part of building up the features, you want to make sure that in your conversations with them, that they have expressed exactly what they want. And it is a very, very difficult thing to do. So how can we achieve this? Biggest thing, talk to each other. Don't have a one-sided conversation. Don't have, oh, here's this big long requirements document, go at it. I've seen this quite a lot. You'll get this very, very detailed requirements document. After about 10 minutes of reading through it, you'll kind of go, okay, that's fine for this scenario. What about this? Person's already given you the document, they've signed off on it, they've said, nope, you're going to go implement that. And you're kind of there going, well, now I have to start making assumptions on what needs to be done, and maybe or maybe not what they want. The next thing I've found is work through examples with them. So say, for example, you're adding in a new logon page to a website. Like, everyone kind of knows what this is. Oh, I go onto this page and I put in my email address and my password and go in. And then the business user might, so that you might go away and go do that, and they come back and they kind of go, no, that's not quite what I want. How do I log in with Facebook? How do I log in with this? How do I log in with this other service? So work through examples. Bring up an example web page, draw a picture, but work through some things with them to kind of give them a little bit of a sense of what it is that's actually going to get implemented. What you'll find is, as you go through the examples with them, they'll keep going, oh yeah, and I want to do this. Oh yeah, and I want to do this. Oh yeah, and I want to do this. That's brilliant. Never, ever, ever, ever say no to those things. What you have to say instead is, that's great, let's put it aside, let's come back to that in a couple of minutes. So never say no to it. Say, yes, we'll get to this at some point, just maybe not immediately. Concentrate on the thing that you're talking about at the moment. So define the specification by example. So work through these examples with them, define them out. Put them down somewhere concrete that you can then reference and have a look at. And ultimately, this is behavior-driven design. So design driven by the desired behavior that the business wants. So there's a concept that is very eloquently put by this blog article here called the Threemigos. So what it's supposed to entail is, it's not just you and the stakeholder having a conversation. If you think about your entire kind of process flow of how things come from the stakeholder thinking about what they want into how they actually get realized in production, there's a lot more than just you and the stakeholder. And specifically, there's three key people who are always involved. There's the stakeholder or product owner or whatever you want to call it, the person who kind of knows what they want. There's the developer, you, the person who's going to implement it, who probably has the most knowledge about how technically it's going to work or how technically it works at the moment. So you know the itty-bitty bits. You know, okay, no, you can't do that, that's just not technically possible. Then the third very, very important person to have here is someone who's involved with testing, because the people who are involved in testing are invariably the people who are the very, very, very best at finding all of the finicky edge case scenarios that evidently will really bring up loads more questions. And they're all usually very good questions. It's like, oh, when I go onto the login page, well, what happens if I kind of go to this place and then go back and then click on the Facebook link, but then hit back in my browser? That doesn't work for me. Should that work? And then you kind of go, okay, well, you'll have a conversation with the stakeholder, kind of go, okay, well, now they're kind of going over to some other part of the website that involves Facebook, and then they're trying to go back here and do a slightly different thing. Should that happen? So yeah, you can ask them the question. The person from the QA will be able to bring a lot of value to that. So that's the Threemigos. So I would suggest that if when you are going through this process with the stakeholder, always have those three people there. Also, 3 people are better than 2, because that's 3 separate people working through the scenario and trying to think up of different things. I would suggest that, especially at the start, try not to make it too big. If you have like 15 people in the room, it's not really going to be that productive, because there'll be a bit too much noise around it. What I'd say is start small and kind of grow it incrementally if you need to bring in more people as you work through the examples. So in particular for this whole BDD process, what I have found is Gherkin is the kind of general syntax that most people use, and Behave is a Python library that I've used, which is very, very handy. Both of them stitch up very well together, both in describing what the user requires, and then also actually implementing automated tests behind it. So why should you do all this stuff? Why should you put in a lot of effort into this? The biggest points I've found when doing this, and I have done it several times with people, and they all absolutely love it when it's done correctly. One of the biggest ones is the clarity of purpose. Everybody knows what's going on. And the biggest thing as well is everybody can reference something that tells them what's going on. There isn't this long email chain that you have to kind of read up and then parse, or, oh, you need to go talk to someone over here, they know this bit. Oh, they need to go talk to someone over here, they know this bit. There is one document that says, this is what I want. And here's the kind of things about the behavior about how it should work. So it also leads to a much greater understanding of the desired functionality. So if the business user is describing to you all the different steps that they want to take, everybody gets much more clued in as to why they want to actually do it. You will find out that as they go through these steps, you'll get a much bigger insight into kind of how they're thinking about the thing that they want to do. And it will also invariably lead to a lot of good thoughts and a lot of kind of insight you'll get about how in general they want their process to work. Because when going through a particular feature, you might suddenly cop, oh, we did this thing 1 month ago that was kind of okay, and we did it, and everyone will say, yeah, that's okay, we moved into production. But it turns out that because we're working through this example here, that really doesn't align with your process. Should we revisit that? Should we make this easier? It'll make these other things easier. So it gives you a very, very good insight into what they're trying to think and what they're trying to do. Next, you get, especially if you automate this and implement the tests, you get living documentation full of examples. Nicholas gave a talk yesterday about how you can use this to generate out actual user documentation, which would be absolutely excellent to do. But even if you don't, you end up with a ginormous document that is hopefully being automated and run every day that asserts that this is the way the system works. But any new person coming along, instead of kind of going, well, you have to read the user manual and then kind of figure out how it goes and step through these things, you can say, have a look at these features here. Follow what they do. Run the automated test. You'll follow the automated test as a click round, but you can see the intent of the behavior behind all of this. And finally, it is a relatively frictionless path to automation, continuous integration, and continuous delivery. If you have a very well-defined set of features and scenarios, it makes it a lot easier to write the testing associated with that, because you know what are the things that you should be targeting. So it helps you hone in those kind of things. Also, if you have a big suite of features, you can use that to automatically check your application to make sure that it works the way that the user behaves. I'm sure we all have like 90, 100% unit test coverage on your code base, but how confident are you in the actual behavior of your application? So how confident are you that your application works the way the user really wants it to work? The code might all work perfectly and all the different bits and pieces work fine, but if, say for example, one user takes a slightly different flow through the application, the process doesn't work or something like that. So this gives you that really good oversight on that, and it gives you an automated way of asserting that. And if it's automated, that means that you get more confidence in your builds, you get more confidence in your application, which means then that you can step up your level of deployment, which then means that you can step up the level of features that you do, and it is a circle that feeds all the way around and basically allows you to deliver a lot more, a lot quicker, and with a lot less effort. So, engaging with the stakeholder. So, you could go into your work and do all of this and try and push forward all of these things, but by far the most crucial thing that needs to happen is you need someone who's going to kind of be on board with you. People are kind of skeptical about this at the start, but once you tend to work through a couple of examples with them, they really do see the benefit of it. And especially what I've found is because we have done this, we've had a lot less complications, which means things have gone quicker, which meant that we're able to deliver more for them, which makes them very, very, very happy. So interested people are engaged people. We're very interested in Python, so hopefully you're all paying attention. That means that you're kind of taking a lot of this on board. I'm sure you've all been to meetings where you don't care what's going on. You're on your phone or you're just looking, staring out the window, and you don't really get what's going on. So you want to have interested people who are engaged, because engaged people become passionate about that idea. And passionate people will stick with it. So they will keep coming back to you saying, yeah, this is great, let's do the next one, let's do the next one. So BDD gives us a lot of clarity about what's going on, and it removes a lot of the wasted time, and most importantly, a lot of frustration about the over and back and over and back. And so that means that there's a lot more time to concentrate on the important things, either getting the functionality done or improving the tech so that you can make everybody's life a lot easier. So I've been talking for 10 minutes now about this, so let's have an actual concrete example about what we would like to do. So a regatta, it is a collection of races, of boats for that goes on, that has some pretty complicated rules around scoring and stuff, but we're going to try and have a little bit of a peek into this over the rest of the presentation and try and give you an insight about what's going on. So what we're doing here is we're defining a feature. So one of the features of a regatta is a race. It's hopefully fairly obvious. So a regatta is a collection of races. So one of the features is a race. So the first thing you define up here is you say feature race. And sorry, this is the Gherkin specific language. So you say this feature is race. Then you give a bit of a description about what you wanted, what's the expected outcome of it. So this is usually in the form of as a, I want to, either so that or because that. So as a regatta organizer, I want to be able to see a list of all races and track their participants so that I can manage the event effectively. Because if I don't know what's going on, I have no idea what's going on, I have no idea who's going to win the prize. So the very first thing we have in here is this, then is a scenario. This is an actual implementation of something. So I want to view all of the races for the regatta. So given I am viewing the nationals regatta, so a national level regatta, when I click on the races button, then I see there are 2 races. And then we have a name, a course, number of laps, number of competitors, if it's completed or not. So as you can see here, we've gone into kind of a fair bit of detail with leaving out a lot of the technical detail. I'd say that the only technical thing in here at all is clicking on the race button. So that's the only kind of thing that would potentially impact the technical delivery. So BDD doesn't necessarily dictate to you exactly how you're going to deliver something. It's all about expressing the desired behavior of it. There are certain things the business users definitely will want to happen, like when you click this button, you have to get a pop-up text with a disclaimer or something like that, or you have to see the banner at the top saying, I accept all cookies on these websites. So there are certain things that will be very, very specific in these. But when you write good features and good scenarios, they tend to be a little bit more abstract while still maintaining that kind of tight expression of what the user wants. So now I will briefly skip through Behave, the technical library that we're going to use. Nicholas gave a very good presentation yesterday, and then also I would highly recommend the tutorial on it because it is excellent. But for the purpose of what we're doing here, I'll give you a brief overview of kind of what's going on and how roughly it works. So, Behave, Python library, obviously enough, that's why we're here. So it works around a couple of different ideas. Overall, when you're running something, you have the environment. That's the overall setup of everything. So that's the entire context in which it's running. Inside of that, you'll have tags. So you can tag specific things, saying, this is UI, this is work in progress, this is really slow, don't run this, doesn't work, this mutates the data. So you can tag certain scenarios and features about things. So inside of that then, when you're running an individual scenario, so when you're running one scenario, so when I'm saying, when I want to view all regattas, you have a context around that. So that's a context that's kind of specific to that. We'll get into some examples in a couple of slides and it'll make a lot clearer. Then you have your individual features. So we saw one previously. So a feature is a feature in a collection of scenarios. And then finally, inside of each scenario, you have a bunch of steps. Steps are the givens, the whens, and the thens. So given I have this, when I do this, then I see something. The tutorial is very, very, very good. I cannot impress upon you how very good it is to get into the nitty-gritty of technically how it works. But I'm going to be concentrating more so on the kind of how you will write good scenarios into that, so I'll be moving a little bit more quickly through this. So this is, the environment is the overall setup here. So it has a number of different things that you can hook into, so before and after each step, scenario, feature, tag, or everything. So it allows you to set up the overall context around all of this. So, for example, before all might be fire up a VM running your application, because that has to be running for everything. So that would be an example of something. Oh, no, don't do that. Skip forward. Okay, so tags allow you to just categorize things. They're very, very useful for for example, marking work in progress things. So test-driven development says you write your tests first, tests fail, then you implement to pass them. Tags allow you to say, okay, this is a work in progress, so don't count this in for our kind of, is everything passing or not? We know this one is failing deliberately, and then we can take it out. They can also mark, for example, tests that perform data manipulation or things that need certain technical things set up. Something that the business user wouldn't really care about, but you know, oh, I need to kind of either fire up just a web application or the web application, the message queue, and database, and everything else. One very handy thing that comes out of this is if you would tag your scenarios, for example, to tag the ones that do read-only things, you can use them to verify your production application then. Because you just point your test runner at your production application, and it will verify that the desired behavior written in your features is actually present in your production application without mutating any data that might cause some problems. So then inside of each step, you get a context that's passed in, and this is basically, it captures any state that you might set up. So any kind of things that are passed in through the scenario definition or anything that's kind of passed along the way that might have been set up in a previous scenario. So say, for example, here we have a table that's set up in the scenario. So we want to check is the string success in the column passed for all of the rows in the table. So we just do something very simple like that. So context is a great thing, but then also can be misused and run you into a lot of problems. So I would recommend that you don't go putting absolutely everything into it. So it's passed from step to step and cleared up at the end of every scenario. So I wouldn't rely on it too much being there, and make sure that kind of things only use it for short periods of time. Otherwise you will end up like the multi-processing example or multi-threading example yesterday, you'll end up with deadlocks of things trying to look for things that aren't there or they got cleaned up by something else. So keep it simple and you'll run into a lot less problems. So a step itself is just a Python function. That's it. You put the decorator given, when, or then, depending on what you want to describe over it, and then it would just, all behave does is says, okay, this is the step for this line, execute it, and that's it. So there's no return values to express kind of does it pass or fail. You have to do that all yourself. So say, for example, here I'm just using assert to just say assert success in page. So the step will pass if it just runs through. It'll fail if it throws an exception. That's it. The steps themselves can be passed using, I think for behave it's parse, cparse, or regular expressions. So you have a lot of flexibility in what you want to put in. But once again, don't get too complicated because you'll just end up confusing yourself. The steps don't dictate the flow of the application at all. They're just functions that you call to do something. So it's I want to do this, okay, call that function. I want to do this, call that function. So all of the control flow is done in the actual scenario itself. So we've been talking a lot about all this. So here's an actual example of a step to kind of get you in it. So this is something that's doing some actual checking. So then I see there are two regattas with the regatta name there. So this is something that you want to assert is there. It's something that tests that the rest of your scenarios have done their correct thing. So all it really is the decorator over the function itself. Inside of here, in this particular one, I'm using Selenium. So I am grabbing a bunch of divs by a XPath, and then I'm just checking that the number of regattas is equal to the length that you passed in, and that's it. Then the second bit I'm doing is that then I just grab all of the rows in that particular table. So in the table we've defined, in the table we've defined up here, I just grab all of the rows out of it, down here. So for row in table, as simple as that, I then check that I have actually found that regatta name, because I could have two regattas, but they could be two completely wrong ones, which means something else is wrong with my process. So you don't want to just check that the number are correct, you want to check that the actual data there is correct. So behave is, I would say, more like the execution framework. It gives you the control flow, as in like call this, call this, call this, call this, I'll do this before, I'll do this after. That's it. That's all it does. So how you go about actually implementing your tests is completely up to you. I mainly use Selenium because I'm testing web applications, but you can use anything at all that you want. You could use, for example, Selenium and Phantom.js to do headless testing. You could use Beautiful Soup to scrape URLs, so you don't need an actual X server, or you can even just execute commands. It's any Python whatsoever. Provided you raise an exception, it'll count as a failure, otherwise it's a pass. So if you have for example, if you have a data flow application, you can still write your behavior tests and express your output. So you could be saying, then I see there are 20,000 rows in this table and they all have this flag set or something like that. So it doesn't just limit you to web applications, you can do it for anything at all that you want. So,
is it easy to plug into an existing suite of tests then? If you would say unit tests or integration tests, could you adapt them to work with?
So the question is, say for example, if you have an existing suite of unit tests or acceptance tests, is it easy to plug into this? So your tests would typically be part of a test class, usually, or a bunch of functions. All Behave requires is that they're put in the correct directory and that they're decorated with the decorator there. That's all it needs. It will then correctly route to that. Inside of that, you just need to make sure that it either raises an exception or that it passes silently. But that would all that you need to do to hook into any existing ones. So you could potentially, if you have a lot of existing acceptance tests written as, say, for example, unit test cases, it would be very quick to port it over to using this.
They couldn't coexist, they would have to kind of
You probably would have to abstract them out because Behave passes in a context, and so say for example here, it passes in the context every single bit like self to every single function, and then also any parameters that are matched in the statements, it will pass them in as separate ones. So you might end up with arity problems between your unit test functions and that. But that will be, I'd say, the only major problem between them.
Is that D stand for decimal or digit?
Yes, digit. Yeah, I ran into terrible problems when I was testing this because this would not match up because I was trying to match a string to an integer. So yeah.
Is there some kind of syntax?
It's the parse, so it uses parse. By default it uses parse, which is a bit like the string formatting, just it parses things out of it. The full documentation is on Behave. You can also turn on regular expressions if you really want to, but I found parse is sufficiently good enough for my needs without being the more complicated thing of the regular expression where you have to kind of stare at it for 5 minutes going, what's this supposed to be doing? All right. So.
Just out of curiosity, if all that's in one file now, unless you don't want to use like Selenium to do a test, can you import as part of that file other modules that you want to do your tests on, or does that have to be done somewhere else?
Behave at the moment, it will look into a particular folder structure to find anything decorated by these decorators. So it compiles up, it scans through a folder structure and it compiles up all the things with the at given, at when, at then, and it then puts them to like its own internal routing database. And then when it runs through scenarios, it'll just call the functions associated with that. So all it does is call the functions. Anything else you'd like to do, you can do yourself.
And just like in those tests, the then decorated test there, the serial graph is
Yeah.
if I wanted to do something that's an API, I would have to do an import statement from my own Python code.
Yes, you'd have to import it in, yeah.
And is it recommended to do that in steps, or do you do it globally?
It would, usually I find that it's more so that if you need to do some external action in it. It usually kind of depends on what you need to do. Sometimes I would just flat out just import it in here and just write the line in and do it like that. If it's something more complicated, I might abstract it out to a function so that it'll be a bit clearer. Because you want kind of, when you're writing the tests here, you kind of don't want to put too much logic in them, because then when you come back to maintain them and evolve them over time, you might be sitting there kind of looking, going, what's going on here? I'm not 100% sure. And you also just want to make sure they're not too coupled to existing kind of your internal private implementation. You would more so want your tests to be talking to like your public API, so your web page or any APIs are exposed, because that's what the business user would be consuming. They wouldn't be looking at, okay, I'm going to import in this module and then I'm going to set up these things and do that. They'd be like, I don't want to do that. I just want to go on the web page and click a button. So I've tended to use these tests to drive the public-facing API tests, which then will test everything underneath it. Ultimately, they're trying to test the desired behavior of the system for what the user wants versus anything else.
Do you have another Selenium example?
Not in this slide deck. But the non-Selenium example would be, I don't know, use the request library to just make a HTTP request, but you'd still probably be inserting the same things. So, what we'll do now for a couple of minutes is step through kind of from top to bottom of how to actually write a feature and scenarios and steps. So the feature, the overall feature, so we're writing a very, very first feature. We want to write it about regattas. So our feature is a regatta. So we saw this one earlier. So our feature is a regatta. As a regatta organizer, I want to be able to see a list of all of the regattas and track their race and participants so that I can manage the event effectively. So that's at a high level what I want to do. I want to be able to do that. So what should we kind of put in these features? The feature block at the top is more like an overall mission statement. It's saying, this is what I want to do. So I find that keeping them clear and concise and putting in the business value into there kind of helps with coming back and readability. It's also a very, very good idea to make sure that when you're writing all these features that they're kind of, they'll have to have a certain amount of business jargon in them, but try not to go too crazy on it. You want to be able to give this to someone else and them to read it and to have a rough understanding of what's going on. You also want to not make any assumptions. So clearly define your initial state for every scenario. Clearly define the set of events that are going to happen, and then clearly define a desired outcome. So what you would not want is that I click the button and then it happens. That's not a particularly descriptive scenario, because that's just I'm doing something and then I don't know what. What you would rather doing is I go onto the web page, I open up this page, I click on the button, I then go to this other page and I see these things appear, or I get an email, or I see this report, or something like that. Something that kind of describes what they really want. So as well, what you will find is the first, and actually when writing this application, I think I have about 8 scenarios in here. The first 2 scenarios took me 70% of the time. So for the first 2 scenarios, I was working through the examples, trying to put in details, and I was standardizing my vocabulary. So I was coming across a lot of common terms that would be reused across a lot of them. So when I was doing those first 2 tests, because I'd done this before, I didn't mind that it was taking 70% of the time. But just something to watch out for, that there's a very sharp curve at the start, but if you write your vocabulary reasonably reusable, you'll find then that there's very little to do in the further on tests, and what you'll actually end up finding is after a while, there's no technical input required at all for certain tests. So you can actually give this to the business users, and they can go ahead and write like 20 other scenarios, and they'll all work because they all use the same vocabulary that you've kind of devised up as part of this. So try and be consistent in your vocabulary. Try and make sure that you're kind of writing the same thing, so that you don't have to repeat yourself, because we don't like doing that. And then finally, try not to tie the features to the technical implementation. So the actual implementation of the steps, as we saw previously, that definitely does have to a certain extent, be tied to the technical implementation. So if it's a web page, I'm going to have to use Selenium. If it's like a HTTP API, I'm going to have to use requests. If it's an email system, I'm going to have to use email. But try not let that leak over into your scenarios and features, because if you do, they'll become very, very specific, and it means that you can't reuse things, and you end up with a lot of tests that describe pretty much the same thing, but just slight technical differences between them, whereas they could have just been a little bit more generic and saved you all a lot of work. So our first scenario. So the very first thing, so I'm on a regatta website. The first thing I want to be able to do is see regattas. So I want to be able to see something. So this is the kind of test, the kind of scenario that I wrote kind of the first time around. So given I open a web browser, so I open up my web browser, and I log on to the sail race scoring website. It's just the name of the website I had. When I view all regattas, then I see there are 2 regattas here. So this is our initial scenario. This one does assume some initial state, In a couple of slides, I'll show you how to set that one up. But this is kind of the very, very simplest of scenarios. So in the scenario block at the top, I've said, okay, this is what it's going to be about. I want to view regattas. Or it could be like, I want to send a reminder email, or I want to complete my checkout, or something like that. The first givens we do are setting up the initial things. So assume someone is coming in from a blank slate. Assume your system is up and running, so you would have to take care of making sure the system is there. But assume the user is coming in from a blank state. So I'm a user on my laptop. First thing I do, I open a web browser. Next thing I do, I log onto the website. Then on this particular website, I see the stuff right there. And then I also want to make sure that I see these particular things. So when you're doing the scenarios, really, really, really try to think in terms of the user. Think in terms of what the kind of steps they're going to do. Even go as far, and I have done it myself, I took out a pen and paper, I opened up my web browser, and I went clicking, and for every click, I wrote down what I did. And then I transformed them into the steps, and then that scenario was actually fairly accurate about what we had to actually do. So, in our previous example here, we had some existing state that was there. So we assumed that those kind of things are there. With the tests, it always should be explicit as to what's there. So you want to be explicit on every step. So you're going to have to set up a certain amount of state. I would highly recommend that you eat your own dog food. So use your own public APIs. Don't rely on some kind of private internal thing. Because if your tests that you're using to verify your own functionality are using your own public APIs, you're also testing your own APIs. So you also have that added boost of confidence. You also get a much better sense as to what's used where. So you can kind of use it to identify endpoints that nobody uses at all. So we can get rid of that. Or what you can say, you will very quickly identify pain points in your own endpoints, in your own public API that you can look at improving, which also makes the lives of some of your users easier. Clean state. Don't assume anything is there before at all. So always work from blank. So always work from the start. Repeatable. All steps should be repeatable. So it shouldn't really depend on, it is the 25th of October 2015. So the 25th of October would be okay because that's a repeatable event every year. But the 25th of October 2015 is one particular date in time, which wouldn't be repeatable. And then finally, avoid poking around in your own database or things in your own application. So avoid database inserts or test-specific things to kind of just fudge it in working, if at all possible. There will probably be some cases where you can't, but just single those ones out and make them explicit. Because if you can avoid doing that at all possible, it means that your tests are just looking at your front end. They're not looking at your front end and also just tweaking something in the background as well, which increases the moving parts, the complexity, and then potentially the failure surface. So we want some initial state. The background keyword helps us to do this for all the scenarios. So basically, it looks like a definition of a scenario, and it's run before everyone. So in this one, the background we have is, I'm on the website. So for us to be on the website, I open a web browser and I log in. And that's it. So that will automatically be run before every single test, which means you don't have to put all this logic in the start of every test. Because if you do, what you'll end up happening is you end up having about that much of setup and about that much of tests. So when you look at something in your text editor, all you're seeing is setup, which is what you don't really care about that. You want to know, okay, given I have a regatta, I don't really, the only test where I care about how that's done is the test that actually creates a regatta. For all the rest of them, it's just initial state. I want that in there. So the background thing, keyword allows you to define something that will be done before every different scenario. So it's very, very handy to do. It allows you to kind of take out a lot of the boilerplate and makes the scenarios a lot more concise and readable and easy to follow. So we have our background data all set up, but now we want to actually pass in some data into a scenario. So we want to say, I want to enter in something. So I want to add these things into my shopping cart. I want to log in as this user. You want to pass some data from the scenario into the step definition here in Gherkin into the actual Python scenario. So there's a couple of different ways of doing this. The main ways are parsing of the actual steps, as we saw an example beforehand. So this, you can use parse or regular expression, and you can just take the string out and put it in. It's very handy for singular things. So say, for example, I click on the races button. So as we'll see hopefully in a minute, what I've done is I've implemented one thing, which is I click on the something button, which was very easy to do. And then I can reuse it everywhere else, because all it does is it find a button labeled that and then clicks on it. So in this particular example, it says it finds a button labeled race and then clicks on it. So I have one step definition there that passes in the data that gets reused further on. So it's not just single values that you'll need. A lot of the time it'll be tabular data. So for example here, we're creating a new race for Agata, or races. So here what I want to do is I don't want to just have to go and I create a race this, and I create a race this, and I create a race this. It's very laborious, lots of typing. It isn't very clear when you're looking at the scenarios. So what you would prefer to do in those cases would be to put in an actual table of results. And it's as simple as this. So you can define a quick table structure here. The very first row is counted as the column headers, and then the rest of the data is passed in. So that's passed in the context on the dot table, and you can iterate through the rows and do that. So they're the main kinds of data that you can pass in to this. Other things that you might need to do would be, say for example, input files or input images. So let's say you're testing out image upload on your website. What you could do is, as part of your behavior tests in the repository, you have an example image. So it's the same image that you use for every single test, so it's repeatable. Or you have a file that you upload for every single test that you've committed into the repository. So you could simply put in here, and I upload the test image, and then you would write a specific step that grabs that image and uploads it. But that would be how you could input something else that isn't just text here. So there will come a time when you feel like you are just laboriously repeating yourself. In this particular case here, I want to test out creating races with a different course. So say for example, in our regattas we have to adhere to some standards, and we're only allowed 3 different types of courses, or 2 different types of courses. I don't want to have to write out the entire scenario block 3 times down, because that's really laborious, just tweaking one particular thing. So what Gherkin allows us to do is to define a scenario outline. And what a scenario outline is basically is, it's like a parameterized scenario. So it allows you to define the scenario and then say there's one parameter that's going to be defined somewhere else later on. So in this particular case, it's the course one. So you can see here, so the scenario would be create a race for a something course. So create a race for a triangle course. So you can pass it in here. You can use it anywhere else at all. So you can use it within tables, you can use it within buttons, or you can use it within strings, anything like that. And the way that it works is Behave will scan this, it'll see this, it'll read in this definition, and then it'll look for an examples table just below it. And what it will do is it will create itself, it'll do the copy paste for you, it'll create a new scenario for each of those 3 different rows in there. So you don't have to do it. So you write this nice, neat, concise thing saying, I want to try it for this, this, and this, and then Behave will pop in, do the laborious bit, and spit out 3 separate scenarios with that one little thing tweaked in between. So it allows you to kind of keep things nice and concise and simple.
Is it possible to kind of say zip the values if you add 2 pairs that you want to do?
Yeah, if you have subsequent columns, so say for example if I had course and laps, it would create a scenario, it creates a scenario for each row in the table. So you can create a table with as many columns here as you want. It'll just create a scenario for each row. So we've gotten to the stage where we've said, okay, this is what I have, this is what I'm doing, what should you check for? This is probably the most subjective and can be the most difficult thing to get right. At the start, you'll probably find yourself writing a lot of laborious things that test for things and keep breaking and need slight tweaking, but persevere with it and you will kind of get it. It's more of an art form, I'd say, in writing the thens at the end, the asserting what you should find, because it's too easy to get really in the fine-grained detail, whereas what you want to do is kind of always take a step back and imagine yourself in the user's shoes, looking at the page, what are they going to do? So, for example, in our courses example here, the user is all they're going to do is look at the page and going to see, I see the word first, there's one lap, it's a sausage, and it's not started. That's all they'll ever check for. They wouldn't really check for, okay, or they may not care that, okay, and this box is over here, and this thing is highlighted over here, and this particular DOM structure is in place. So the users are kind of checking things at a higher level. So try to keep that in mind when you're writing thens to avoid getting stuck in the kind of nitty-gritty technical bits. So the rough kind of categories of things you will test for is the check for existence. So you have nothing, you created something, then you have something. So I have an X of these, I've created a number of these. I have something with the name this, I have something with the name this. Checking for state transitions. So say, for example, adding things into a shopping cart. So when you click the button, then you see that the item is in the shopping cart. So when I click the button, then I see that it is in here. What I would really say is try to, when you write out your scenarios, try to execute them yourself. So write out all the scenarios with everyone, and then just sit down at the computer, look at the scenarios, and literally do what it says. What you should find is you get 95% of the way there. There will always be a little bit of fudge room that you may need to revisit. But if you're kind of writing your scenarios kind of hopefully as kind of specific but not too specific, you'll find that if you just literally sit down and follow them blindly, like monkey see, monkey do, you'll be able to navigate your way through them. And if you don't, have a look at that, see why that particular step didn't quite work, and then maybe tweak it a bit to either change the wording, change what you're checking, change what you kind of slightly need to do. So you are the best and worst, most forgiving and most error-prone behavior-driven design runner in the world. Behave and other libraries will literally do what you tell them to do and nothing else. So it's a computer program, it does that and that's it. You as a human will have a little bit of a fudge. You will kind of do things slightly differently. You'll spot things, you'll have an intuition about things. So always, always, always run through your own scenarios yourself when you're implementing them. It will give you a much deeper insight into what's going on, and then also it will probably end up saving you a lot of time in the long run, because you'll kind of go, oh, look at that, that probably shouldn't be happening. Maybe I'll raise a bug for that one, and then, or that doesn't quite work out. Maybe it should be done this way. So always try and look through your own work. Finally, keeping scenarios interesting. So I have come across problems where due to the kind of the initial setup, scenarios are like this long. Incredibly boring to read, because what you actually wanted to do was skip down about 2/3 of the way down, and that's where the interesting stuff started. So try and leverage the different tools that Behave and Gherk can give you to keep the scenarios short enough, but then also interesting and engaging to the users, so that people, when they read them, they're actually paying attention to them and they're not just reading text and glossing over. So an easy to read scenario should be a story. It should be describing you where you're coming from, what you're doing, and where you're going. So it should be a narrative, a story. So keep that in mind. Okay, now hopefully the demo will work, and then also hopefully in the 6 minutes I've left, I will be able to give you a brief overview of what one of the full-on scenarios look like. So what we have here so this is the website that we've all been talking about. I didn't want you to have a look at the website beforehand. I wanted you to read through the scenarios so that you yourself have built up, hopefully, a picture of what should happen here before we even look into it. It's like, I suppose, it's like the TDD process of, if you write the code first, you're not really writing very good tests, you're just writing tests to satisfy the code. So I wanted you to think through and run through some of the scenarios first before we actually even look at the website itself. So this is the main regattas feature. I think I have 4 in this file. So as you can see here, these were in the presentation, so hopefully they're all familiar. So I have a bit of background here. So I have opened up a web browser, I log into the website, and then I also set up 2 regattas ahead of time. Then our very first scenario is view regatta. So when you log onto the website, the very first thing you're going to do is you want to look at some stuff. So this is one we covered earlier, that you're just logging on, checking that the regatta's names are there. That's enough for now. The next one is, so after you see that a regatta is there, the next logical thing you'd like to do is add in your own one. So you'd like to add in a new one. So here we have kind of getting into a little bit more of the details. So given I am viewing all regattas, so that makes sure I'm on the correct page, and then all the setup stuff will be done. But that's what the user will be doing. They'd be going into the website and say, okay, I want to create a new regatta. So first thing I'm doing is I'm looking at them all. Then I click on the add regatta. Then I click on the add regatta button. So I click on a button saying add, and I enter my regatta name in the regatta box, and then I click the add button down below. So this is literally what the user will be doing. Then I see now that there are 3 regattas, so that my add has been successful. So that's, I've gone from some initial state, I have changed something in the system, and they've asserted that that's changed, and I now have output. And hopefully I will be able to run that specific one, and we'll all be able to see it. This is line 24. So to give you a brief insight here, so behave is the name of the command. Stop simply says stop on the first error. D says debug an error, so it launches a PyDB shell when it errors. It's very handy for checking DOM state at that particular time. And then what I'm saying is run the regattas feature file, and then only run the scenario defined on step 24, because I want to show that one in particular. The debug an error was something that I put in. It is on the Behave tutorial, and it's very, very handy. So as you can see here, it's opening up the web browser, it's loading in the application, it's clicking the add button very quickly, and it's typing in all of the regattas, and then it is hopefully asserted that's there. But because it hasn't closed the browser window, something has gone slightly wrong. So this particular scenario didn't quite work as intended. So if we have a look at the output here, what we can see is this was the entire run. So Behave will print out to you what it's doing, and then any errors that happened. So it says, okay, this is the feature, it's defined on this line. This is the background that I'm going to run for everything, it's defined on this line. This is the scenario, it's defined on this line. I'm not going to do anything because I told it to skip it. Then it will come down here, and this is the scenario in particular that we're looking to run. So it was line 24. So it then prints out every single step that it does, the Python file that it called to do it, and then how long it took. So it took, for example, 3.2 seconds to open up the web browser and then log on to the page. So this will give you actually a rough sense of kind of where the timelines lie and things. So you can see it's stepped through here. So it's opened up the web browser, it's logged onto the website, it has put in the all of the regattas. If you'll notice, this came from the setup background. So Behave is automatically inserted in that, so we don't have to do any boilerplate ourselves. So the bit that we actually wrote in particular for this one is, given I'm viewing all regattas, which succeeded, because it's green, when I click on the add regatta button, that was fine, and I enter my regattas, and it's fine, and I click on the add regatta button, that went fine. Then I see there are 3 regattas. So we should have seen just those 3 regattas. And then it says, nope, that's not the case, because I actually found 4. So it's stopped at that particular point and said, nope, that doesn't work. So if we continue on the debugger and let it go all the way through, Behave will give us this kind of nice overview here. So we had 0 features passed, 1 of them failed, 0 was skipped. 0 scenarios passed, 1 was failed, 2 skipped. 7 steps passed, 1 failed, 15 skipped, and 0 undefined. So it gives us a nice overview as to what's actually going on here. Now, the actual problem with this one is in the web application, I was testing it and I hard-coded in some initial state, so that's why the numbers are all wrong. So the tests aren't picking up that one correctly. So that's why it's not exactly working. So it's a bug in the application that it is putting in state, whereas the test should be putting it in.